Hi everyone, this is Lindsay, and today we're going to talk about the effects of yawning. So, for most people, I'm pretty sure that you might have heard at one point or another in your life that yawning is contagious. That is to say, that when one person yawns, the other people around this person will be influenced to yawn too. And I've always wondered whether that is just a myth or is that scientifically proven. So a few days ago, I saw a BuzzFeed video discussing this topic. So what they did was that one particular BuzzFeed video staff sat at a room of the same setting with other BuzzFeed staff. Um, so he sat with one BuzzFeed staff at a time, and then he pretended that they're gonna do a burger taste test. And then while waiting for the burgers to be brought to them, that original first BuzzFeed video staff yawns, and he records whether the other person yawned too, or they just sit there and do nothing. So I think he did that with like less than 10 people. I'm pretty sure it's like around 8 or 7. And then like most of them yawn, so he got to the conclusion that yawning is indeed contagious. After watching that video, the credibility of BuzzFeed is completely shattered in my life. Not completely, but I this as we can all see, this experiment is poorly designed. So I was determined to conduct an experiment that will actually help us scientifically figure out whether yawning is contagious. So what I did is to first design this experiment. In order to get a diverse sample, I took advantage of the opportunity of being in Disneyland, and you know how people from all over the country and even the world flies to Disneyland to have fun. So that guarantees us a diverse sample subject group. Later, we find that there might be lurking variable from that population, but as of right now, this is the subject group that we chose, and the population is, of course, all people who engage in a conversation. And then, so what we did is that whenever I myself have the chance to engage in a conversation with one person, I would throw a coin first, and then to decide whether this person goes to the control group or whether I yawn during the conversation. So I engaged in the conversation at around 1 minute with 35 people, and we flipped 35 coins. So after that, we had 18 people randomly be selected as the control group, and the other 17 are selected as the subjects who will actually get treatment. So this is the design of our experiment. And after that, what we did is, during the conversation for the control group, I would do nothing, and I'll see whether they will just yawn naturally. And for the treatment group, I would, during the conversation, yawn and see if they would yawn in response. So here, let me demonstrate you my sample results. Well, actually, in this case, we're not gonna show you that result, the table of that result directly. Please refer to the write-up. But in the end, what we had is that 5 people out of the control group naturally yawned, and the rest 13 people didn't yawn. For the treatment group, 8 people yawned and 9 people didn't yawn. So according to that, we now have the data that we need, and we can get to the bottom of this. We just need to find the appropriate statistics test for this situation. As we can see, whether a person yawn or not yawn is not a variable that can be accounted by a number. So this must be a proportion test. So what kind of test are we looking at? We actually chose a two-sample z-test. As you can see, we do have two sample, one control group and one treatment group. And so let me pull out the test. So first, what we did is we followed the state plan do conclude 4 steps, and what we did is first the state part. We are conducting a two-sample z-test to test whether yawning in a conversation really have a statistically significant impact on people, on the true population proportion of that person who yawn in a conversation. So our null hypothesis would be P1 equals P2, and our alternative hypothesis is P1 is smaller than P2, and P1 represents the true population proportion of people who yawn in a conversation when the partner in this conversation does not yawn. So this represents the control group or the control population. And P2 represents the true population proportion of people who yawn in a conversation when the partner in that conversation does yawn. So then we move on to the plan part. We have to test the 3 conditions to see whether this whole experiment is fit for a two-sample z-test. So the 3 conditions, we are all very familiar about: random, normal, independent. Random, yes. Whether the person that we meet gets a control treatment or the treatment of yawning is randomly determined by flipping a coin. So the random condition is satisfied. And second, the normal condition. We know that in a two-sample z-test, we need to make sure the successes and failures are all greater than 5. So n1 times p1 hat is, as we already said, is 5. And n1 times 1 minus p1 hat is 13, which is also greater than 5. And in the treatment group, the same happened. 8 is greater than 5, 9 is greater than 5. So the normal condition is also satisfied. Now we just need to look at the independent condition. Specifically for this experiment, we engage in two partner conversation. When I did talk to a group, I only look at one, the main conversation person. So you know how like in a conversation of more than 2 people, when I yawn, and if that person yawns, then that will affect the actions of other people. That might affect the actions of other people. So that's why we make sure that the conversation are only engage 2 partners. Therefore, the independent condition is satisfied because each subject's response is independent and thus not influenced by each other. Now that all the conditions are satisfied, we can move on to the two-sample z-test. First, we need to get all the data out, P1 hat, P2 hat, 1 minus P1 hat, 1 minus P2 hat, and then PC hat, which is P pool. So, calculating all the proportions from our data, we get that the P1 hat is 0.278. So the 1 minus P1 hat is 0.722. The P2 hat is 0.471, and the 1 minus P2 hat is 0.529. And the P pool hat is 0.371, and the 1 minus P pool hat is 0.629. Plugging all the data that we have in the equation, which is z equals P1 hat minus P2 hat over the square root of P pool hat times 1 minus P pool hat times 1 over n1 plus 1 over n2, and we got a z-score of minus 1.1798. So with this z-score, we are easily able to find the p-value, plugging into our calculator to find, using normal CDF, we found that the p-value the right tail is 0.1190. This is considering that our alpha level previously stated is 0.05, we can move on to the conclusion. Because our p-value equals 0.1190 is greater than alpha equals 0.05, we fail to reject the null hypothesis and conclude that there is no sufficient evidence that when one person yawns in a conversation, the proportion of the other person yawn is greater than that when the first people does not yawn. Therefore, based on our two sample z-tests, we know that yawning does not create a statistically significant impact on whether the other person in the conversation yawns. Well, speaking of, our experiment is not exactly perfect, in which case later we found several lurking variables. The first one is pretty obvious as of right now. I'm sure you already figured it out. All of our subjects are selected in one location, so it is considered a convenient sample. We chose our subjects, the sample in Disneyland, which might be a lurking variable because people go to Disneyland for fun. So they are naturally more excited and less tired, and therefore less inclined to yawn. And also, my fake yawn skill, as demonstrated in the beginning of this video, you can see that is pretty lame. So my fake yawn might not even gain the attention of other people because it is so lame. Therefore, this is also a lurking variable. Therefore, the number of people who actually might yawn is underestimated due to the lurking variables. So this is the weakness of our experiment. So although errors have been made, this is generally a well-designed and interesting experiment for which not only did I have the chance to apply statistics knowledge in real life and solve a real-life problem, but I also improved my skills to talk to strangers, which at times can be intimidating for me, considering I am not a native speaker of English. So through this project, I also learned to design an experiment in a way that minimizes errors, and I learned to conduct an experiment, carrying out all the procedures. This project invoked my interests in social experiments and social studies, which I might actually explore more in college. Therefore, as we can see, whether yawning is contagious still remains a controversial topic. Many scientists have conducted discrete experiments to test this theory, but according to our data, although there might be lurking variables, yawning is not actually contagious. So I hope you enjoyed this experiment, enjoyed this project. I hope this knowledge helped you to live your life, and I hope that the ways I design and conduct my experiment help you learn more about stats. Thank you.